So what we can show you here tonight quickly, it's going to be pretty cool, is we actually have, courtesy of our friend Steve Mead at SMD, we have one of his signal generator and impedance meters, IMSG.
Those things are awesome.
These are cool. And we're running a tone directly in. Now, it's a tone right now, and I'm actually going to put it onto pink noise.
Will that play below 40 hertz?
It'll play below 40 hertz. If it's got Steve's name on it, it plays below 40 hertz. So as you can see, I've activated the pink noise. So what we've got going on here is we are running pink noise, and I need to move it down here to the KMC2. So I'm moving the pink noise down to the KMC2. And again, guys, we do all this stuff live right here on the camera, so you can see what's going on. There's no hokey pokey. There's no hanky panky. Turn yourself around.
And you want to take the RCA output.
Take the RCA output.
Yep. Also connect that.
We're moving it from the KMC5 compared to the KMC.
So what we're going to do is we're going to measure the RCA output of the KMC2 to the true RTA to show you frequency response.
Okay, so what I want you to do, John, if you'll fire that up and play me pink noise, and what we're going to do here first, everyone, is we're playing pink noise off of a USB stick. So obviously this is a pink noise track that is, let me hit go here on the RTA so I can get that fired up, John. Okay, I should be ready if you want to give me a signal.
It should be playing.
Okay.
Have we got it?
I don't have anything yet, but I got no pinky noise, so I'm just looking here to see what's plugged or unplugged.
We said pink noise active.
So
all these cables we got up here.
I got signal. There's signal into the focus, right? So here we go.
Yep.
I just need more signal.
Oh.
I need more.
You want it more louder?
I want it more louder. Give me more gain. I want more gain.
How much you want?
I want more gain. Give me more gain.
That's about it. That's all you get.
All right, so I'll get a little more gain here on the focus, right? So I can.
All right.
All right, so Ernie, I'm a fan of many companies. As far as content information format, Kicker has the game on lockdown. RX Boom, thank you for that. That is a sincere compliment that means a lot to us because we put a lot of time and effort into this, and we appreciate that you're getting something out of this because that's what it's all about, so thanks, man. So what we're looking at here, this is pink noise being played out of the KMC2 radio, and as you can see, pretty flat and consistent. Pink noise is never going to be a perfectly flat line. It's going to dance on both ends of the spectrum in the middle. That's just the way pink noise works and the way your RTA averages. But as you can see, yes, it definitely plays. Let me get my mouse pointer here so you can see.
I guess something else we better check to make sure all the tone controls are set flat.
Make sure they're set flat, John. So right here where my pointer is, there's the magical 40 hertz. So does the radio play below 40 hertz? Yes, the radio plays below 40 hertz, absolutely no problem at all. And then Ernie, go back, and what I want to show you is down here at the end, this is 20 hertz, or 20 kilohertz, excuse me, 20,000 hertz. And you can see that 20,000 hertz, it drops off pretty significantly right here. And John, let's go from playing on the USB drive, change me to the auxiliary input, which is getting fed the signal from the SMD. And lo and behold, hey, looky there, 20 hertz is back.
Yep.
So guys, what you're seeing here, you can see it's pretty much the same curve as you saw before, but when you get down here into the upper frequency right here, what you were noticing, when we go back to the USB, you'll see 20 hertz falls way off. That's what's happening when that track is compressed through the MP3 algorithm, and then you play it back. So here again, all we're doing is changing inputs. We just went from the auxiliary input that's getting a pink noise from the SMD generator. That's the signal we had. Now we're looking at the USB stick. That's the one that Ernie just had up there. And you're seeing how far that 20 hertz falls off. That is from MP3 compression. And let me tell you, compression, music, MP3, all that is a subject that's near and dear to my heart. There's several guys in this feed that have had, I don't know if they're cursed or blessed, to have spent some time around a campfire with me and talking about this topic, because you can spend all the money and all the time, you can focus on all this gear, and I want the best subwoofer and the best amplifier, and I want everything to be the best. But then if you don't worry about what you're playing, what goes in is what comes out. Yeah, if you have poor quality audio going in, you're going to get poor quality audio coming out. And we've experienced this on pink noise, and guys go, well, man, I just can't get 20K to come up on my graph. I was like, well, what are you using for a source? Well, MP3. You're probably never going to get 20K to come up on your graph. It's going to fall back into that 18, 17 range, and it's going to start rolling off, and that is because of the MP3 compression that's going on. So I think it's pretty cool that you can see not only does the KMC2 pass 20 to 20, but it also does as good as it can with USB, with an MP3. But when you go into the aux input, it's flat.
Now, I think it'd be interesting if we can do this with one of these shows, but they'd have to have headphones on, or a really good system hooked up. We actually have some tracks that we actually cut between MP3 and like a WAV file as we play it, and you'd be astonished the difference in the sound quality. I mean, you see it a little bit by the graph, but when you actually hear the difference side by side, it's pretty amazing.
Okay, so here you go. This is the RTA playing off of the USB thumb drive, and as you can see, it's got that roll off at 20K, just like we saw. That's going to happen on any of these using an MP3. That's just pink noise that goes to an MP3 compression algorithm. The top end gets rolled off pretty severely on that.
But look at how much flatter the low end response is.
Yeah, it is.
I mean, that's because it's got an entirely better preamp and
better preamp, higher voltage, everything.
You're buying a better radio.
So now what I want to do, John, is I actually want to run this up, and I want to look at clipping on the oscilloscope.
All right.
So what you can see here, guys, on this oscilloscope is I'm turning the volume control up and down on the KMC5, and as you can see, we're playing a 50 hertz tone, and as that signal gets smaller or less, you can see the wave gets taller, not as tall, not as deep. And as I turn it up, the wave gets bigger and bigger. So what I'm looking for here is I want to turn this up until we get just to clipping. And right there, you see that flat part at the top? That's clipping.
Where, the top up here?
The top and bottom. Well, both our heads are clipped, but it's because we've hit too many trunk doors and hoods and
hatchbacks.
Exactly. So I'm going to turn it down one notch. And you can see right there, and I'm going to hit auto scale so it'll bring everything into focus there. So now you can see that is a clean maximum. If I turn the radio up one more notch, if I go one click up, I'm into clipping. So I'm going to turn
one click.
One click. Now I'm clipping the top. And that right there, you're probably looking, that's probably somewhere between about 1% THD is what we're probably looking at there, is about 1%. And if I go further, and you can see the further I go into clipping, the wider that gets, the wider that gets, the wider that gets, and there, that's right there.
It really falls apart at that point.
Preamp says, what do you want me to do? And so that's really bad. I mean, you're clipping, the signal's falling apart, you're into hard clipping right there. You're over 10% THD.
At that point.
It's garbage.
Well, I should say that, but some people listen to that.
Look at them waves. So I'm going to turn the radio back down. I'm going to get out of that clipping mode there. Okay,
there's give me some clean output. Kid.
Yep, I'm bringing it down. So there, right there, we are right at the maximum clean output. Now what I'm going to do, guys, is I'm going to push voltage here, and then I'm going to go down here and I'm going to push voltage RMS. And what it will do is, boom, it'll tell me. And right now, coming out of that RCA preamp out is 4.194. I mean, it's going to vary because things jump up and down, but it's about 4.2. There's 4.3, so let's just call it 4.3 volts RMS. That's what we're getting out of here. So clean, unclipped on the O-scope, coming out of a KMC5, I'm getting 4.3 volts. So John, I'm gonna get out of the way. I'm just gonna walk off here. Do the math and show us, what does that mean?
We actually have more than that. So if we did the math, are we measuring the preamp out on that? Because we should be a lot higher. We should be about 10 volts.
Well, that's a good question, John. I don't know. Let's take a look.
To give you an idea, I mean, what we're looking for. So if we have 10 volts, let's just say we have 10 volts and we squared divided by 4. So 10 squared is going to be 100. Divided by 4 should give us 25 watts. Don't know if you can see that. Yep, you can see that right over Kip's shoulder. So once again, we'll take voltage divided by the resistance. If we have 10 volts squared, we get 100. Divide it by 4 ohms, that'll give us 25 watts of power. So that's how we do that, but we absolutely have to know that's a 4 ohm load.
I moved the ground probe, so I probably didn't have it on the right spot. So I'm getting 8.1, 8.2, so 8 squared.
So 8 squared is 64.
Yep, so that's what I'm getting. That's what I'm saying, 8.14, 8.155.
That was a nice looking omega. All right. So
yeah, 8.2. Yeah, between 8.2 and 8.5, it's fluctuating.
So 8.5 times 8.5 equals 72.25. Divide that by the 4 ohms. So completely unclipped, it's 18 watts.
So right now we're getting 18 watts. Completely clean, unclipped.
Yep. Okay, and once again, you can get a whole lot more when you start adding, 1, 2, 3, 4, 10% distortion.
Well, let's, you know what? Since we can. Pink noise. I want to go back to,
You want a sine wave.
yeah, I want a sine wave.
So you should be at 40 hertz.
Yep, 49.5. Okay, so let's do that. Let's actually take this up.
And if you go ahead and show the O-scope again, Ernie.
Okay, so now let's look at voltage. Voltage RMS. All right, 10.35.
So that's obviously going to be 25 watts. So 10.35. I could type 10.35 times 10.35 equals divided by 4 equals, so that's 26.78 watts.
26.78 watts.
Which is about what we claim.
Which is about what we claim, which looking at the O-scope, I can tell you that's right about 10% THD. I mean, that's about what 10% clipping looks like, is something right there. So if you can get a good look, okay, Ernie, go to...
We like playing with Ernie.
Go to camera 1, Ernie. Come on, go camera 1. There you go. No, go there. Go. There. Stop it. Okay. So as you guys can see right here on an O-scope, this is what 10% clipping looks like. As you can see, it's no longer a clean waveform. This would not be pleasant to listen to. Is it power? Yes. Is it output? Yes. Is it voltage? Yes. But at 10% THD, this is not something I'd want to listen to. I'd find it pretty grating and poor. But as I turn the volume knob down, you'll see that waveform will come back into. You can see it keeps coming down, and boom, right there we're back to a clean waveform. So hopefully. And then I'm going to turn it all the way down, just get it out of there. So I'm going to come back around the table, John, join you. So that's kind of a trip. I mean, that is actually how you can calculate power. You can look at an O-scope. You can see when things clip. You can then measure that voltage. You can then take that voltage to the very easy formula here. And as long as you know the fixed load you're running into, whether it's 1 ohm, 2 ohm, 4 ohm, whatever it is, you can easily calculate the math. Yep. Now, what's cool about that last one John just did, it came up to, it was 10 something squared. What was it? 100?
10.35.
All right, but what's that into a 2 ohm load?
Actually, if it was that voltage, it would be double, like 56 watts.
So it would be about 56 watts at 10% THD.
Because, like I say, if it does whatever voltage it did, I mean, if you're going to take a 2 ohm load, you're going to divide it by half rather than 4 ohms. So
exactly.
It's going to be 50 watts power. So the other thing that we really got to point out is it's not linear, guys. I mean, just because the voltage doubles doesn't mean the power's only going to double. Actually, as the voltage doubles, it's quite a bit more than double the power.
Right.
Because of the scale that works. Now, the other way we could do this, the other power formula is power equals current squared times resistance.
Which is another way to get to Grandma's house.
So if you guys want, there's an app, just do Ohm's Law app, you can actually get those online for free and it'll tell you all the formulas. I mean, there's basically 4 different, you got power, you got voltage, you got current, you got impedance. So with those 4 variables, there's an app that'll tell you if you know 3 of the 4, it's going to tell you the 4th by
you
doing
can figure out the last one.